All right, we'll go through the problem I asked you to sort of work on a little bit. You have two non-rotating balls on a frictionless surface collide elastically head on. You can think about the curlers. The curlers, you have on ice and they collide those rocks. They call them the rocks. I don't know if you guys watch the Olympics at all, but they call them the rocks, the little curling things that they slide down and they sweep in front of. Those are called the rocks. Um, yeah, they elastically head on. They collide. The first ball has a mass of 15 grams, initially a velocity of 3.5 meters per second to the right, while the second ball has a mass of 22 grams and an initial velocity of 4 meters per second to the left. Final velocity of 15-gram ball is 5.4 meters per second to the left. What's the final velocity of the 22-gram ball? Okay, so what we have here, we have two masses sliding on a frictionless surface. Let's see here. The one is traveling to the right at 3.5 meters per second, and the other one is traveling to the left at 4 meters per second. Let's see, the second one is 22 grams, and the first one is 15 grams. Okay, they're going to come together. They're going to collide, okay, elastically, which means they will bounce backwards. Okay, so what we have here is we have two objects that are in motion coming towards each other. Two objects coming in motion towards each other, and then they're going to bounce backwards the other direction. One has more mass than the other mass. They're traveling at different speeds also. Okay, so after the collision, let's see here. The final velocity of the 15-gram ball is 5.4 meters per second back to the left. So afterwards, it's going back to the left. We want to know what the velocity of this object is. Because if they collide elastically, they're going to bounce in different directions. They're going to bounce backwards. So we can, since we have elasticity, we can do either of the scenarios. Kinetic energy will be conserved or momentum will be conserved. Now, momentum is a little bit easier to deal with here, but since we say we have elasticity, at least elasticity, okay, we're elastic here, we're going to have both potential and kinetic energy are conserved. Since we're on a frictionless surface, we don't lose any of our thermal energies or any energies into non-mechanical energies. But I like to use the momentum idea just because it's a little bit easier to work with. So we have total momentum prior to and total momentum afterwards. If it's being conserved, they must be equal to each other. So my M1V1 plus my M2V2 prior to interaction has to equal M1 V1 prime plus M2 V2 prime. Okay, our momentum prior to has to equal our momentum after. Now what you have to watch out for here is velocity, we have to worry about directional ideas. If I go to the right being positive, to the left being negative, so if I'm moving in this direction, I am positive. If I'm moving in this direction, it is negative. I need to put a notation or a positive or negative sign in with this. So summing in, we have 15 times 3.5 plus 22 times a negative 4. Okay, need to make sure we get our negative in there since we're going to the left. Is equal to 15 times B1 prime, which is 5.4 or negative 5.4. Negative 5.4, because I'm going back to the left, plus my M2 V2. So we have 22 times V2 prime. Now, questions you may have is, well, we're in grams here, and I'm conserving momentum. Well, momentum is mass times velocity. If all my units are in grams, I can convert them all to kilograms, and I'm going to get the exact same solution. Because what would I have to do is I'd have to divide everything by 1,000 here. Okay, but ultimately I'm not trying to find a mass, I'm trying to come back to a velocity. So I could go 0.015 plus 0.022 plus 0.0 equal 0.015 plus 0.022 and make my numbers a little bit smaller. But since I'm multiplying and dividing by everything by 1,000, I don't have to worry about that. But I do have to worry about my directions of my velocities. Okay, so if I'm going to the left or if I'm going to the right, I need to make sure I have a directional idea there. And once again, if you change them all to kilograms and work through the kilograms, that is fine. Your numbers just will be a lot smaller. Okay, I'm working through with grams, so my numbers are a little bit nicer to work with, and I don't have a bunch of decimals that are sitting there. But once again, making sure that you have directions with your velocity is important. Now, if we use conservation of kinetic energy, my velocities are being squared, so the negatives would cancel out at that point. Go ahead and solve for your B2 here, if you've not already. Negative 35.5 on the left. Times 5.1, you get 81. 5.4, get 81. So we can add our 81 to both sides to solve an equation here and divide by 22. Amber, what do you get for final velocity?
2.07.
2.0 what?
7.
Okay, 2.07, which means, and that's a positive, which means I'm going to be going back to the right. They're going to rebound and go back in the opposite direction. Once again, we could use 1/2 mv1 squared plus 1/2 m2 v2 squared equals 1/2 m1 v1 prime squared plus 1/2 m2 v2 prime squared. We can, since we're elastic, we can use the idea of conservation of kinetic energy and be able to come down to the same solution if we would sub in. The nice thing about this is all your velocities turn into positive here. There's a few more calculations that, and as you go through this, if we're conserving momentum, we could multiply through by 2 or divide through by 1/2 and get rid of those fractions. And if we go through the calculations with our kinetic energies, we should come down to the exact same velocities. Once again, I would, if just looking at mathematics, I would sit there and multiply through by 2 and get rid of the 1/2. We get 2.11 meters per second, which is close to the same velocities. All right, what I would like to do today is allow you to finish or continue to work on your homework. Monday is going to be a review day. Tuesday will be a unit test over the entire chapter 6 of momentum. This is the last of our material. So Monday will be, once again, a review day, but I'd just like to give you more time to work on your homework and go through the homework. And once again, that's very adjustable next week. I might test on Tuesday, maybe on Wednesday. I'm not sure. We'll see how you guys feel about the work that we're doing. Okay, so rest of the time is yours to work on your homework. Any questions you have about anything on the homework? I think we've hit most of the types of problems here in class.